In this lesson, we discuss bump and normal mapping in V-Ray for 3ds Max. Using bump and normal mapping, you can simulate grooves and imperfections like wood grain, for example, on a surface. Always remember when using bump or normal mapping, unlike displacement mapping, you only simulate the effect of the grooves and indents. You don't actually create new geometries. Let's open up the material editor and run the IPR. I have already applied this V-Ray material to the shader ball. First, we obviously need to define a map to be used as our bump map. Let's start with just bump mapping and we'll discuss normal mapping later on. In this case, let's just add a procedural noise node and decrease its overall size to around 4. As you know, V-Ray material has a bump map input, and this is a more straightforward way of bump mapping. So let's simply connect the noise map to the bump map input of the V-Ray material. Now you can clearly see how our noise texture causing bumpiness and unevenness on our shader ball. Remember, this is just an illusion. The actual geometry is unchanged. Look at the outline of the geometry. It's perfect. The silhouette is a straight line. To control the amount of bump mapping, simply select V-Ray material. Down in the maps section, you can control the bump amount. The default value is 30. Let's try 10, 30, 60, 100, and 200s. In this case, let's set it back to its default of 30. And for now, let's disconnect the noise map from the bump input. The way I like to work with bump and normal mapping is through what's called V-Ray normal map node. Let's see how that works. We can try a simple image here to drive our bump mapping. So add a V-Ray bitmap node and load this parquet underscore bump texture. We can actually view the image to see what we are working with. Great. And now set its tiling to 0.5 so it sits larger on the geometry. And as it is a data input and we are in ACES, we can set its RGB color space to raw, or we need to set its RGB color space to raw. Now, instead of directly connecting it to the bump map input of the material, first we connect it to the bump map input of a V-Ray normal map node. And then we connect the output of the V-Ray normal map node to the bump map input of the V-Ray material. This will give us the exact same result as if we connected the texture directly to the bump input of the material, but now we can control the amount of bump mapping through this V-Ray normal map node, and it will also allow us to define a normal map, which we'll be discussing it in a moment. For example, let's set the bump map amount to 0.5, 1, 2, 5, 10, and so on. So as you can see, where the texture is white, we see bumps, and where it is darker, we see indents. For now, we can use 1, which is the default value. Now let's talk about normal mapping. You can use normal textures, this kind of purplish textures, instead of the regular grayscale images. When you use a grayscale image, as your bump map, you are only specifying 2 directions, up and down. But normal maps are RGB textures and can give a direction to the bumpiness effect. Now let's see how it works. I'm going to add a V-Ray bitmap node. And let's load this wood underscore parquet underscore O2 underscore normal map texture. We can click on this view image button. You can see it's very detailed. For now, disconnect the bump map, and now you just need to connect it to the normal map input of the V-Ray normal map node that we have already loaded. Now, to see what's going on better, we can increase the normal mapping strength to 5, and we just need to flip the green channel to make it work correctly. And that's it. Now we get this beautiful normal mapping, which feels more realistic compared to simple bump mapping, as the input map has more data and information. If we select the normal map texture, you notice its color space transfer function is set to none and its RGB color space is set to raw. And this happened automatically. For normal maps to work as expected, you need to make sure this happens. If not, do it normally, but it's automated. So normally, pun intended, you don't need to worry about it. Now we have a few options in the normal map node. First off, we have strength or normal map amount, which increases or decreases the normal map effect. Let's set it at around 10 for now. You can also flip red and green channels of the map and swap red and green as well. That's it really. Now we have this parquet normal map applied to our surface. Let's say in addition to this, I would like to have a noise map to add some general unevenness to the surface. So let's use the noise map that we already added and simply connect it to the bump map input of the V-Ray normal map node. Now we get the noise as our bump map while still keeping the normal map. I can decrease the bump height to something like 0.25 centimeters. Now we added that overall unevenness underneath the parquet normal map. And now we get this complex surface where the noise adds an overall unevenness and the parquet texture adds the details. Later on, we'll learn that in real world, most of the surfaces are not perfectly made. There is this overall waviness to them that can be easily recreated with a noise map, which we did it here. Then we used a detail normal map to simulate the type of surface that we are working with, which was this parquet texture in this case. Also, there is a material in V-Ray called V-Ray BumpMaterial. So let's add one to the editor and see what that's about. You notice this material has a base material input where you can define the material that you want to add bump or normal mapping to, a bump map input and a bump amount value. First of all, this material allows you to add bump or normal mapping to any material that might not have a bump map input on its own. For example, if I disconnect the V-Ray normal map node from the bump input of our V-Ray material, then select the V-Ray bump material and assign it to the shader ball, and then define our V-Ray material as the base material for the V-Ray bump material. And now connect the V-Ray normal map node as the bump map input of the V-Ray bump material. We get the same result but through a V-Ray bump material. Now let's say we have our basic white V-Ray material. Now let's add a new V-Ray material and change its diffuse color to a light pink. Now add a V-Ray blend material and assign it to the shader ball. Use the white material as the base material and the pink one as the coat material. And as the blend 1 map, we can load this BW27. Okay, so that's the material that we get. Now we can go ahead and apply our bump mapping to each of the white and the pink materials separately. But if we want to have the same bump or normal mapping for both, we can assign our bump material to the shader ball again. And this time use the blend material as the base material there. And now our previous bump and normal mapping is basically applied to the entire shader. You can also use this bump material to chain up multiple bump and normal maps. Let's add one more layer of complexity by simply loading a new V-Ray bump material, assigning it to the shader ball, using the first bump material as the base material. Now let's connect another V-Ray normal map to the bump input of the new bump material. And connect this floral pattern texture through a V-Ray bitmap node to its bump map input. and maybe decrease the bump amount in the new V-Ray bump material to 5. And I get this floral pattern on top as well. And this makes everything more complex. You can go ahead and add as many bump material as you want this way, but I think you get the concept. Cool. For now, let's close the frame buffer. I'm gonna hide the shader ball and unhide this cubical shape that has very sharp edges. And let's say we wanna round those sharp edges through a shading trick. I'm gonna create a new V-Ray material and assign it and run the IPR again. Let's quickly talk about another shader that relates to bump and normal mapping, which is V-Ray Edge Text Map. We can actually load it. And this map or node has a round corner feature if used as a bump map input. So let's connect its output to the bump map input of the material. We can obviously kind of connect it through a V-Ray normal map node if we wanted to. Now you can use this radius value to control the amount of roundness. In this case, something like 0.25 turns our sharp corners into beautiful beveled edges. You really don't want to use high radius values here as it won't be realistic and it will introduce artifacts. It has some other self-explanatory options that you can go through on your own. So that's about bump, normal mapping, bump material, and round corners in V-Ray for 3ds Max. See you in the next one.